Hi, I'm Stan Voynick, and I'm the Chief Engineer at Sierra-Olympia Technologies. One of our products is the DRS Tamarisk. It's a small, fully featured, long-wave infrared camera. And as the master distributor for DRS in North America, Sierra-Olympia has shipped thousands of these Tamarisks out to customers in all kinds of different segments of the industry. One of the things that our customers have been asking us for is a USB interface to make it even easier to connect to this camera. And so with this USB-C connector on the camera here, it's the standard oval connector, just like you might find on a modern cell phone. With this connection, you can plug the Tamarisk into a computer, and most Windows computers will just wake up and recognize the Tamarisk with its USB interface as what's called a UVC type of driver. Now, if that's a technical term that you're not familiar with, that's okay, because the whole point is that Windows takes care of the drivers. Because we made the Tamarisk USB compatible with the UVC class of video driver, the Tamarisk appears as something like a webcam. The basic operation mode of the Tamarisk USB is so standard that you don't need to use a thumb drive to install a driver or find a disk or go download a driver. Windows knows how to interact with a UVC type of interface, and that's how it works. Now, at Sierra-Olympia, we have a philosophy of camera as component, and many of our customers are technical customers, engineering integrators, where they may be using our systems and integrating them into higher level products. In that case, you might, the standard round consumer type USB connector might not be the ideal thing. So we've designed this interface. It's actually a two-board interface, a two-board stack here. And I'm going to pull off the top board. The top board is actually just the connector interface. That's the part that has the commercial consumer type connector on it. That board comes off the stack, and in that case, what we're left with here is what we call our OEM connector. The actual USB interface is on this board, so it's still present, and what we have left here is an OEM connector. Now, this is a standard commercial connector from the company Samtec, and all of the USB capability is present on this connector. So what this allows our technical integrating customers to do is to create their own circuit board, which would take the place of our connector board and do whatever functions they need to without needing to have the consumer USB connector, and typically there's a cable that comes off of that. You can literally design your own circuit board, and we will offer you the reference design for our connector board as a starting point for that effort, so that you have all the holes in the right places and the connector is exactly in the right place to plug on here. And you can create your own interface to this board through our OEM connector. And what that allows our technical customers to do is they can then take the USB interface off in whatever direction they need to go. They can even integrate, could even be a larger board with other functions integrated right on the back of the Tamarisk in that case. So that's a nice feature. Now, I mentioned earlier that the sort of the out-of-the-box experience is to plug in the Tamarisk USB and to use the UVC capability of it. That stands for USB video class. It's the video driver class within the USB standard. When you do that, it's a kind of a standard, either black and white or colorized by color palettes type of thermal image that you may be used to seeing. The other question we get from our technical users then is, okay, I know that the inside of the Tamarisk has a 14-bit data path. In other words, the image data that comes from the long-wave sensor in the Tamarisk and ultimately gets processed starts out as a 14-bit, sort of a higher dynamic range data path. And indeed, that's correct. Ultimately, once we get to the point where we're displaying it, we need to generally crunch that down to about 256 levels, effectively an 8-bit data path. But the 14-bit data path is available. And the question comes, okay, well, with this new USB interface, can we get the 14-bit, the full dynamic range data out the USB interface? The answer to that is absolutely yes. There's some mode switching to be done, fairly straightforward, and the 14-bit data gets presented. It actually gets presented in a 16-bit data path onto the UVC interface. Now, the thing to remember is the UVC interface, this is standard, and I'm using USB and UVC interchangeably here. USB is the overall standard. UVC is the USB video class. That's the protocol within the USB standard that we're using here. The UVC protocol that I just mentioned does have a 16-bit video class. However, if you're in this 16-bit mode, most of those generic pieces of video software or webcam display software or whatever won't recognize, they don't know what to do with 16-bit data, because that's sort of really a scientific application. So generic video display programs don't generally work for that. So we have two options for that. One is we actually have our own piece of software that comes with the Tamarisk USB that is a viewer. There are controls to adjust the gain and the offset so that that wide dynamic range data still gets converted down into a displayable 8-bit screen, essentially. But it shows over here, you can see that the dynamic range, this is a histogram, so this is intensity on this scale. The dynamic range spans all the way up to 16,000, which is a 14-bit data path. And that's where our data is currently residing, in that 14-bit data path. So we crunch down the limits of that so that we get good resolution on the screen. So that's a way of having it in 14-bit mode, but still being able to display the data and look at it and manipulate it and so on. The other thing is most of those customers who are asking us about interacting with the 14-bit data are wanting to do something with it, wanting to pull that data into a computer, into a processor of some kind, and they don't want to scale it down until they get a hold of it and do their own mathematical processes on it. That is absolutely doable. It's easy to do. I challenged my software colleagues to come up with as small an implementation as they could to demonstrate how you can interface with the Tamarisk USB and get the raw image data into a computer with the smallest, tightest bit of code. And they claim that they can do that in something like 12 or 14 lines of Python code. Now, we use OpenCV, which is an open source library that's easily available. And it does a lot of the kind of under the hood interfacing that's needed. And so literally with 12 lines of Python code, and along with the reference design that I told you we make available for this circuit board as a piece of hardware, we offer you essentially a short reference design of the code needed to access the camera, to open up access to it, and then to start pulling that 14-bit data path into the computer so that you have buffers full of images to manipulate, process, and do whatever else you need to. So that's our new USB interface for the Tamarisk USB. It's a new interface on a mature product that will help our customers continue to integrate and create new applications and to do new functions. Thanks a lot. I'm Stan Voynick, Chief Engineer at Sierra-Olympia Technologies.